Okay, I think we're live.
Hello, everyone, and welcome to another Axelar Learn. We're really excited to be having this one today. We've got some very in-depth, amazing content for developers. So if you are a Web3 developer out there who is looking to do more with DeFi, looking to do more with Uniswap, hopefully this video is helpful to you. So we're going to be learning a little bit from Ben today. Ben is a developer advocate here on the XR team, and he actually just spent the last 2 months traipsing across Europe and having a jolly time. But we are happy to have him today. Ben, I will hand it over to you to talk a little bit about how we're going to be learning and what we're going to be learning today.
Thanks very much, Stephen. Great to be here. Let me just share my screen here. There we go. Yeah, so thanks very much for the intro, Stephen. It's good to be back home in Toronto after a long time in Europe. So my name is Ben Weinberg. I'm a developer advocate with the Axelar team. And yeah, we have a really exciting agenda for us today. We're going to first start off with a brief overview of Axelar for those of you who are new to the community, who maybe don't know very much about Axelar and what we're here for. So we're going to go over Axelar. We're then going to get into general message passing. I'm going to refer to it oftentimes as GMP. And this is a super important feature which Axelar has enabled, which we can make use of for the Uniswap demo, which is what we're going to end with. We're going to have some Q&A with whatever time we have left for those of you who are on the live stream. So without further ado, let's get to it. So Axelar at its simplest form is a blockchain that connects blockchains, enabling universal Web3 interoperability. Now, there's a lot to unpack there in that sentence. So I think the actual easiest way, and I'm going to refer to the sentence again in the future, but I think the easiest way to really understand Axelar from a 50,000-foot view is to look at this diagram that we have here. So you can see Axelar is a service that is allowing us to connect different blockchains. We're currently at 55 different blockchains that we connect, and they all connect through Axelar via a hub and spoke model. So every transaction that wants to go from one chain to the other goes through Axelar. Now I want to go back to this definition here and focus on the last three words right now: universal Web3 interoperability. That sounds a little jargony, but it's extremely important. And I want to go over explain this by looking at some of the chains that we have connected to Axelar. So let's look at the top left corner here. We have chains like Ethereum, Polygon, Avalanche, Phantom. These are chains that are running the Ethereum virtual machine powered by proof of stake. We also have chains like Osmosis, Juno, the Cosmos Hub. These are chains coming from the Cosmos ecosystem that are built on top of the Cosmos SDK with Common BFT. We also have chains like Arbitrum. We have, though not on this chart, we have Linea and Base that are also connected to Axelar. These are examples of layer 2s on top of Ethereum that can now talk to any of these other chains. And what I'm trying to show here is this idea of universal Web3 interoperability. It doesn't matter what consensus mechanism your chain is on. It doesn't matter what virtual machine your chain is running. It doesn't matter basically how your chain is built. Axelar can connect you to the entire Web3 ecosystem. Any questions so far? Let me actually check here. Cool. I'm going to keep going here. So that brings us to our next topic of general message passing. It's an amazing feature which Axelar has for us right out of the box. And what is it in simplest terms? It's exactly what it sounds like. It's the ability to send messages between one blockchain to the other. So the easiest way to see this is this little diagram right here. I have a picture of myself here on Ethereum and myself on Avalanche. And you can see on the top line here, I'm sending a very simple hello world message from Ethereum to Avalanche. But general message passing is a lot more powerful than just hello world messages. You can do things like send messages, which you'll use as a parameter in a function call on another chain. You can even literally call functions on other chains by sending the function signature. So for example, in the second line here, I'm calling like SafeMint 5 Bored Apes. I'm able to actually conduct that function call from one chain by sending the function signature to the other chain as a GMP message. So to go a bit deeper on how this works, we can look at this diagram here. So let's step through this together. Imagine we have a smart contract powering some dApp, which we have deployed on two blockchains. So if you look at the bottom left corner here, we have our dApp, which is deployed on Ethereum. And on the bottom right corner, we have the same dApp, which is deployed on Polygon. Now imagine we want to send a message from our dApp on Ethereum to our dApp on Polygon. Under the hood, what's going on is we're going to be interacting with something called a gateway contract. A gateway contract is a critical piece of infrastructure which Axelar has for us, which we can basically import into our dApp. And the gateway contract exposes several different functions which we can use to trigger our interchain transaction. One of those functions is call contract with token. And when we call contract with token on our dApp, we will basically be kicking off this interchain transaction. When we call this, the gateway contract is notified and emits an event. This event is then submitted to the Axelar network. Remember, the Axelar network is a blockchain itself, which is powered by delegated proof of stake. It has 75 validators, and these validators will basically come to consensus about this message that was sent it via the gateway contract. Once it comes to consensus about the message, so for example, if we're sending a hello world message from Ethereum to Polygon, it'll come to consensus about that. It'll then notify the gateway contract on the destination chain. Remember, every single blockchain which is connected to Axelar has a gateway contract on there. So the Axelar network notifies the gateway on the destination chain that they have approved and come to consensus about this message that was sent. The gateway then via a relayer will call a function called execute with token, which will live on our dApp. And then we can run whatever logic with that message that has come in. So in the case of a hello world message, we can just emit an event on our destination chain that says hello world. So I know it's a lot. Let's step through it one more time. We have our dApp, which lives on Ethereum and Polygon. The dApp imports the gateway contract, triggers a function called call contract with token. The gateway emits an event. The event is picked up by the Axelar network. The network comes to consensus about it. It notifies the gateway contract that, hey, we have a message coming in from the source chain of Ethereum. The gateway contract on the destination chain, then via a relayer, triggers this execute with token function, which will handle some logic with the message that was passed in. So the demo we're going to be doing today using this basic flow is going to be with Uniswap. So in this previous slide here where I was showing a simple GMP message where we're just passing hello world, or we're passing a function called a SafeMint548, what we're going to be doing here is with the call contract with token function. Remember this function which is exposed by the gateway. We're going to be sending AXL weth, an Axelar compatible version of weth, as well as a message which contains the exact input singles param, which is required by the Uniswap swap router contract to conduct a swap. So before we start writing the code, I'm going to actually jump into the Uniswap docs very quickly, see if we have any questions so far. Nothing yet. Good. Yeah, we're going to look at this Uniswap docs very quickly. So we're going to basically be replicating this function right here on the Uniswap docs. Let me make it a bit bigger so you guys can see. And basically what we're doing here in this function is we're swapping in an exact amount of a certain token in. So in this example, they're swapping in DAI. So we can be swapping in like 10 DAI, let's say. And based on how the AMM works, we're going to be getting a set number of weth back, or weth9 here, depending on how the AMM is valuing DAI to weth9 at a given time. So we're going to be actually sending in this entire struct, exact input singles param, as our message across Axelar from one chain to the other. On our destination chain, when we receive this message, we're going to be calling this exact input singles function, you see with this params, which is this guy right here. And then we're going to conduct a swap on our destination chain. So I'm going to leave this up here one more time just to get the 50,000 foot view of what we're doing again before we step into the code. We're sending weth, and we're sending this struct, and we're conducting the swap on Ethereum here, on Uniswap. So let's get right to it. Any questions? Cool. So we start off with a blank contract here with a couple import statements that we have. Let me close this. And I'm going to step through these import statements before we start writing up our contract. First thing we're importing is an interface for our ERC20 token. This is just an interface so that we can interact with ERC20 functionality. We import the Axelar executable. I'll make this a bit bigger so you guys can see. We import the Axelar executable, which I will come back to in a few minutes. We import the interface for the Axelar gateway. Remember the gateway, that is this guy that I was referencing back in this slide. It is what will allow us to trigger our interchain functionality. So we import the interface for that, which comes from an Axelar NPM package. We then import another critical feature called the Axelar gas service. And this guy I haven't spoken about yet. So let's get to that actually. So when we are sending an interchain transaction from one blockchain to the other, you guys are probably wondering, what about the gas, right? So in this example, we're going to be going from Polygon to Ethereum. So think about it, we need 3 units of gas. Why 3? Well, we need Matic to pay the transaction cost on Polygon. We need AXL to pay the transaction cost on Axelar, because remember, Axelar itself is a blockchain. And then we need ETH to pay the transaction on Ethereum when we're triggering our functionality there. And I don't know about you guys, but I don't want to have to worry about managing 3 different tokens every time I want to make an interchain transaction. And that's where the gas service comes in. It basically allows us to extract away that difficulty of having to pay 3 different transaction costs. And it allows us to pay this entire interchain transaction in the token of the source chain. So if we're going from Polygon to Ethereum, we just need to hold Matic. And then we can pay the Axelar network as well as the Ethereum network, or the Ethereum blockchain, I should say, for this transaction. Just to clarify, that doesn't mean that we're getting subsidized in any way by Axelar. The money's still coming out of our pocket. It's just coming out in the form of the token of the source chain. And you'll see us using the gas service throughout this demo. Then we import our Uniswap helpers, which we'll use to actually interact with Uniswap functionality. So let's get to it. First thing we want to do is write up our constructor. So we will need the address of the gateway, as well as the address of the gas service. Remember, every contract, every blockchain which Axelar is compatible with has a gateway and a gas service running on there, because we need to interact with both of these services, the gateway and the gas service, to actually conduct a transaction. So we're going to pass the address of the gateway into the Axelar executable. We're also going to inherit from it. Axelar executable, which I imported up top there on line 6, basically provides some helper functionality for executing the transaction on the destination chain automatically. Don't worry too much about that for now. Just know that it contains the gateway. It contains an instance of the gateway, so we can just pass the address of the gateway to it, and then we'll have access to our gateway. We will then pass in the address of our gas service to a gas service variable, which I will create right now. So I Axelar gas service, make it a public variable gas service. Switch semicolon. Cool. So now we have our gateway and our gas service addresses connected to this contract. Let's actually start to write out some of the functionality to conduct this interchain swap. So let's call this function just like interchain swap. And then it's going to take in several parameters, which I'll explain shortly. It's going to take in our destination chain. It's going to take in our destination contract address. And it's going to take in, our symbol of the token we're passing and the amount of the token we're passing. It could be an external function which also accepts ETH or native tokens. So what is going on here? What are these parameters? Well, this is the name of the destination chain we're transacting to. So if we're transacting from Polygon to Ethereum, this will just be Ethereum because that's where we're going to. The second parameter will be the address that we're transacting to. So once we get to Ethereum from Polygon, like where on Ethereum are we going to? We need an address. So that's the address we're going to be passing in here. So address on the destination chain we're transacting to. Remember, in addition to passing in our GMP message, our exact input singles param, we're also passing in weth. We're passing in a token and a message. So this is the symbol of the token we're passing from Polygon to ETH. And this is, as you can probably guess, I'm just going to even copy it, the amount of the token that we're passing from Polygon to ETH. I hope this is clear. These are the 4 parameters we're going to be needing to conduct this transaction. So the first thing we want to do is actually get the address of the token which we're sending, which we can get with our gateway contract. So we grab the token address, we interact with our gateway. Remember, gateway is, sorry, I know I've repeated it a lot, but gateway is this contract, which we need to trigger a transaction. So our gateway contract has a function called tokenAddresses, which we just need to pass the symbol in, and it knows to pass us back the correct address of the token. So this is the address of our AXL weth token. I'll even leave a comment here, because this is the token we're going to be sending and eventually swapping. Now, we can actually run some basic ERC20 functionality. So what we're going to want to do now is send the tokens from our address, my unique EOA, to this contract, which will be living on, at first, the Polygon blockchain. So let's go tokenAddress, transfer from, message.sender to this contract. And how many tokens are we going to be sending? We'll send the amount. Next, we need to approve our gateway contract to handle this token on our behalf. Because remember, we're going to be sending this token from this contract via the gateway contract to Axelar. So we need to approve the gateway to actually handle these funds. Okay. So at this point, when we call this function, we're going to send ERC20 tokens from us to this contract. Now we get to the interesting stuff. We go back to the Uniswap documentation. Remember, we're going to need to be passing a message to the Uniswap swap router contract. And we're going to be basically need to be telling it what are the params of our swap which we're conducting. So I'm actually just going to take this directly from the Uniswap documentation, and we'll customize it for us. So we're passing in the token in. Which token are we swapping into the DEX? So for us, it's going to be wethGoerli. It could also just be the token address. The token that we want out is Uni-Goerli. We're going to be swapping weth for Goerli. Let me actually just grab the address here of Uni-Goerli. I'm just hard coding it here for the sake of this demo. So even though we're going to be deploying this on Polygon, we're going to actually be conducting the swap on Goerli. So we need the address of the Goerli address of this token, not the Polygon address. Next, we want to pass in the pool fee. This I'm going to take directly from Uniswap's documentation as well. How much we're going to be paying the Uniswap pool or liquidity providers. I'm grabbing this from here. So 0.3% fee that we're going to be paying. The recipient of this transaction is going to be us, the message sender. Deadline is going to be block timestamp. I'm going to actually put it +1 hours just in case, for whatever reason, the transaction takes a long time, that we don't run into any errors here. How many tokens are we swapping in? Well, that's just going to be the amount. And we're going to leave these last two parameters 0 as they had in the documentation. Great. So now at this point, we have taken tokens, ERC20 tokens, from our contract, sent them to this contract, and conducted what will be the message that we need to send to the Uniswap swap router contract. The issue is that for a message to actually go through on Axelar GMP, it cannot handle, the Axelar network can't handle this this random struct, right? Exact input singles param. It needs to have a set type of a message. And the type of that message that we need to pass in is of type bytes. So we're going to encode this swap params. Let me actually rename this to swap params. Params. And I'll call this encoded swap params. And we will encode this simply by writing API encode swap params. So now we have this struct as a type bytes. And that is what we can use to actually send to the Axelar network to be received on the Ethereum blockchain from Axelar. So now that we are basically done with our Uniswap functionality, let's actually get back to the Axelar functionality. Remember, there's two critical services we need to interact with for an Axelar transaction. We need the gas service and we need the gateway. The gas service is, of course, to pay the gas, as I explained before, of an interchain transaction, and the gateway is to actually trigger the transaction to go to the Axelar network. So let's start off with paying the gas to the gas service. So we're going to call this kind of mouthful of a function, but a very accurate name, called pay native gas for contract call with token. Okay. This is, as the name suggests, paying for a contract call with token. So basically, a type of transaction which we're sending a token with, because we're sending weth along with our GMP transaction. And we're going to be paying for this transaction with the native token of our blockchain. So for Polygon, that's Matic. So let's pass in a message value to pay for the transaction. Let's also add this required statement up top here to make sure that, like, hey, if you don't send any message value, then just revert, because the transaction won't work. Let's say like insufficient gas sent. Now we know that some message value be sent to here. Let me delete this actually. And now let's send in our parameters. So who is paying this transaction? It is this address. Where is it going to? These are the parameters that from up top. So where's the transaction going to? It's going to the destination chain. Where on the destination chain? The destination contract address. What is the message we're sending? It's going to be this encoded swap params. What is the symbol? And what is the amount? And now we have a lovely error, which, what did I do wrong here? Pay native gas for contract. Oh, we're missing an argument. Oh, yes, one of our most important parameters. So when we are paying for the gas cost of an interchain transaction, we're going to be passing in a message value here. Now, there are services to calculate exactly how much gas we need to pay for this transaction to successfully take place. But for the purposes of this demo, I'm not going to get into that. I'm just going to pass in an arbitrary gas amount. Okay. Now, if we overpay the amount of gas we're sending, let's say I said 10 Matic, just because I really want to make sure this transaction goes through without any issues. If we do overpay, like the transaction actually doesn't need 10 Matic, then it will refund us the difference of what we paid. And this last parameter is basically saying, okay, where do you want the refund to go to? So I want it to come to me. So I'm just going to pass in message sender. So now if we pay 10 Matic and it costs 1, we'll be getting 9 Matic back to this message sender address. Great. Now that we've paid for the gas, we need to pay for the we need to execute our call contract with token function. Remember, that is this guy that we were defining here on this slide. This is exposed by the gateway contract, and it'll, as soon as we call this call contract with token, assuming we paid our gas, then this will actually trigger the interchain transaction. So it needs a bunch of parameters too, which should look familiar. Those are the destination chain. What is the name of the blockchain we're going to? What is the address on that blockchain that we're going to? What is the message that we're sending? The symbol of the token we're sending, because remember, this is contract call with token. We're sending a token along with our message. And what is the amount of tokens that we're sending? Let me make sure there's no questions here. Nothing yet. Good. Yeah, so I hope this is clear for now. I'm going to review this function again because this was a lot. Just going to make the screen smaller so it can all fit. As soon as I call this function, we have to make sure we've paid some gas. We then grab the address of our ERC20 token of our Axelar weth. We then transfer that token to this function, to this contract. We approve the gateway contract to execute this token on our behalf. We construct our Uniswap message that we're going to be sending to the swap router. So we're basically saying, like, which token are we swapping in? Which token do we want to get out of the Uniswap DEX? How many tokens are we swapping in? We then encode this giant struct into a bytes type message. We then pay the gas with the Axelar gas service to pay the entire interchain transaction. So pay for it on Polygon, pay for it on Axelar, and on Ethereum. And then we trigger our call contract with token function on our gateway to actually fire off this interchain transaction. So at this point, once I call this function, we will have completed the first step of this demo. We will have sent a transaction to the Axelar network. At this point, this will all execute under the hood. The Axelar network will come to consensus. It will then send a message to the gateway contract, but we're not done yet, because once we are now at our destination chain, it's going to be like, okay, what do we do now? So we need to implement step 4 here, execute with token, to actually execute some logic based on our message that has come in. So I'm actually just going to copy and paste this directly from here into our code. Execute with token. We are marking this as an internal function, and we are actually overriding it from our Axelar executable, which we're inheriting from. This is where it's defined, right down here. So you see it takes several parameters here. I'm not going to actually make use of many of them. I'm just going to make use of the payload. But I'll go over them because they're worth actually familiarizing yourselves with them. So if you are calling this function on the destination chain, you might want to know, like, hey, who actually called this function on the source chain? What if it's a malicious actor or some random actor? What if it's coming from the wrong blockchain? So that is what you can check here. This will say exactly which chain the transaction is coming from, and this will say who is the source actor, who's actually triggering this transaction. Payload I will come back to because we're actually going to be using payload. Token symbol and amount are, well, which token was sent and what's the amount of the token that was sent. So let's actually pass these in here. I'm going to keep these undefined. We have to pass them in because it's a function that we're overriding. Token symbol and UNT-specific amount. That should get rid of our error message. Good. Now the payload, which I ignored before, this is super important. What is the payload that is getting called here, or is getting passed in? Well, that is our GMP message that we're passing in. So if it's a hello world message, then the payload would be hello world, or an encoded type of hello world. If, in our case, the payload is this swap params, which we've encoded and passed in here as our general message. So we're going to need to actually decode these swap params to interact with our Uniswap swap router on a Goerli. So let's do that. We're going to grab exact input single params. Let's, for extra clarity, call it decoded GMP message. ADI decode. We're going to decode our payload. So this guy right here. And we are decoding it to this, to exact input single params. Great. So now we have our message that has been sent from Polygon to Ethereum. Keep in mind, this this function is going to be executed on Ethereum, not on Polygon. It's going to be executed automatically by an Axelar relayer. So the first thing we want to do is decode this message. Now that we have it, we can call the swap router. Let me actually, I don't think I put that in here. I'm just going to hard code this swap router. This is Uniswap's address. Keep this here. So this is the address of the Uniswap swap router on Goerli, where we're actually going to be conducting the swap. So with our swap router, we're going to be executing this function from our Uniswap documentation, exact input single. We'll call here, and instead of params, we're going to be passing in the GMP message, which is this message, which was encoded, sent across Axelar, and now decoded, and now we're passing it in basically exactly as we did as Uniswap did on their documentation. The last thing we have to do is approve. Let's see, wethGoerli. Let me grab this in. This is the address of the weth token on Goerli. Let's actually, with wethGoerli, approve our swap router to swap this on our behalf. And we're going to be telling it to swap. We're going to be approving the specified amount that we received. And that is it. So we, at this point, I've gone over this function several times, but we send in a GMP message from Uniswap. It gets received, from our contract, which is compatible with Uniswap. So this message is now sent from Polygon, travels through Axelar to Ethereum, and then on Ethereum, we will execute automatically. This function will get executed automatically. Let me delete this comment. It'll decode our GMP message, approve the Uniswap router to execute, to handle the tokens on our behalf, and then execute the swap. And it should be working now. So we have several deploy scripts. For time's sake, I'm not going to go over these deploy scripts. They're pretty straightforward Ethers.js deployments. And this code will all be available after the demo, so you can check it out if you want. But basically, we're going to deploy this contract on Ethereum and on Polygon. And then we're going to conduct this transaction on Polygon. And we're gonna hopefully, I mean, Murphy's law of live coding, but hopefully this should work. So let's compile this guy with hard hat. And now deploy on Goerli. So we have, let me make this bigger so you guys can see. So now we have an address on Goerli. Let's deploy on Mumbai, on Polygon. Now we're going to use our hard hat console to interact with this contract. Make it a bit bigger. So we can use contract interchain DeFi. Interchain DeFi is the name of this contract to get our Ether's contract factory. We will then attach our address on Polygon, or on Polygon Mumbai, to our contract factory. Now we should have a contract instance. This contract instance, we should be able to interact with it now on the Polygon block explorer. So let's say I want to call this public variable here, gas service. Gas service. Great. You see, we're actually able to interact with a live instance of this contract. We just called this public variable, which returned us the address of the Axelar gas service on a Polygon. Now let's actually get to the fun stuff. Let's call this function, interchain swap. So we go await contract interchain swap. This is going to be a bit of a longer one. Interchain swap, we have to pass in now these 4 parameters. So the name of the chain that we're going to. Axelar has Goerli registered as Ethereum-2. So we're passing in Ethereum-2, which is basically code for Goerli. The address that we're going to on Goerli, well, that is this address that we just deployed. It's this instance of the contract on Goerli. We pass that in here. We pass in the symbol of the token that we want to interact with. So AXL weth. Then pass in the amount of the tokens we want to interact with. So let me just pass in like 0.1 weth. So that is 1 with 17 zeros. And now let's pass in 0.1 matic to pay for the gas. Remember, if we don't pay for gas, then we'll get in trouble with our revert message here. Great. So we fired this off. And now you see we have a transaction hash. Which if I go to the Polygon block explorer, Polygon scan, oops, an old one, I can actually see this transaction executing. Great, and we have now sent 0.1 weth to the Axelar gateway contract. But what if we want to actually see this entire transaction? Because remember, there's a lot going on here. We're dealing with 3 blockchains. We're dealing with Polygon, Axelar, and with Ethereum. What if we want to see this interchain transaction taking place? That is where testnet or Axelar scan comes in. So Axelar scan is basically our block explorer. It's a really neat tool which Axelar has built. You can also see here a bunch of fun stats about the Axelar network. So the 55 chains we're connected to. You can see a more up-to-date version of the map, which I had on the slides earlier. So you can see all of the chains which we're connected to. Some stats like we hit 1 million transactions recently, 7 billion in volume gone through us. This is actually the wrong URL. We want to go to testnet.axelarscan. So you can see the numbers here are a bit different. But what we want is to actually see our transaction. So let's throw in this transaction hash here in the top right corner. And you see our transaction actually taking place, going from Polygon to Ethereum. Note, we have an issue. We have not sent enough gas. We sent in here, wherever our code is, we sent in 0.1 ETH, with 17 zeros, and that's not enough to cover this transaction. Fortunately, there is a solution to this. On Axelar Scan, we can just easily click this Add Gas button, which should pop up MetaMask, which will allow us to pay the missing gas amount that we need. So you see it costs 0.25 extra ETH that we're missing out on. So we confirm this here. If we were to have paid more gas, let's say we paid a full matic, we wouldn't have had to do this. This obviously would have executed automatically. But hopefully in a second, we should see that the gas service is now happy and that we have paid enough gas. And we can actually see the step-by-step, here it is, it's happy now. We can see the step-by-step of an interchain transaction taking place as it's going. So you can see here, sent. I can actually click on this little Polygon icon here, which will take us to the same link that we had here before, same transaction hash. So you can actually see this transaction taking place on the native block explorer of that blockchain. When this is all done, it should be done in about 3 minutes once the transaction finalizes and goes through the Axelar network. But once this actually goes through and takes place on Ethereum, we'll be able to see the link to Etherscan on our Etherscan Explorer. But I don't want to keep you all waiting for too long. So let's actually go here, and you can actually see a full transaction that has taken place. From Polygon to Ethereum. And I'll show you guys the other transaction once it's finished completing. So you can see here the full transaction. It was sent from Polygon. This is what we had before. It got confirmed. In other words, it was finalized on Polygon, got approved, step 4 on the Axelar network itself. Marked as approved on Ethereum. It was marked as approved by the Axelar network. And then lastly, you see that it was executed on Ethereum. So if I click on this little Etherscan icon here, it'll take me to Etherscan, and I can actually see the transaction taking place. You can see here this Uniswap, so whatever, load. This is the address for the Uniswap pool, this 4D18. You can see it is returning us Uni token, which is what we specified as the token that we want. And it is taking from us our weth token. So it's swapping weth and providing us back Uni. So the transaction actually works. Let's see if it went through. It's still going through on our previous transaction. But that is a high level of actually conducting a swap. Let's go back to Axelar Scan. From Polygon via Axelar onto the Ethereum blockchain with Uniswap. Let's see, that was a lot. Let's see if we have any questions. Yeah, in the meantime, while this transaction is executing, hopefully it should be done in a couple minutes. You guys feel free to ask questions. I want to pull up some other helper slides here for us with some QR codes, which if any of you guys are interested in building more with Axelar or learning more about different use cases of Axelar, highly encourage you guys to check out these links. On the left, I believe, is a YouTube series which we have from the DevRel team on like they're quick, easy to understand videos of using Axelar GMP and other Axelar related functionality. So that's our left QR code here, which you guys can scan. On the right is a link to our Axelar examples GitHub repository, which I highly encourage you to check out. These are full in-depth examples using Axelar. So like sending a simple GMP message, a bit simpler than what we just did. Sending like kind of what I call like ping pong messages. So like sending a transaction from one chain and then automatically having that sent back to our original chain. Sending tokens from one chain to the other, and many, many more examples here on our Axelar examples repo. Some of them even have like front ends, so you can see like the full stack Axelar application. So I highly encourage you to check out both of these links here if you guys are interested. And yes, that is it from me. My name is Ben Weinberg. Thank you very, very much for listening. If you have any feedback for me about this talk, feel free to scan the QR code and provide any feedback. And yes, that is it for me. I will provide, this is still executing here, I will provide the transaction link to this working transaction shortly. But yes, thank you very much. Any questions while we're here, just before we end here? Cool. Great, everyone. So thanks very much for joining, and I will see you all at the next talk. Thank you very much.